Now let's take a look at limit. What is an idea of an limit? So let's see. Okay, let f(x) equals to 1 over x. Okay, and when x equals to 1, fx equals to 1 over 1 equals to 1. Okay, when x equals to 10, fx equals to 1 over 10, meaning 0.1. When x equals to 1000, fx equals to 1 over 1000 equals to 0.001. What if x equals to 1 million? Then fx equals to 1 over 1 million. Then 1 over 1 million equals to 0.0000001. Meaning, we have a conclusion when x is 10 to infinity. Okay, this symbol is infinity. Then fx 10 to 0. Take note that in this chapter, this arrow, it means approach, or we say 10 to. And this symbol, same as this one, it means infinity. What does infinity means? Means the number becomes extremely large. And note that when n tends to infinity, it doesn't mean that n equals to 0, equals to infinity. It just means that n is getting nearer and nearer to the infinity. But doesn't mean that n equals to infinity. Now let's take a look at this example. Given by the questions, limit n tend to 0, 1 over 4 plus n. And what is the answer? Okay, first, you write when n equals to 1, when n equals to 1, this equals to 1. 1 over 4 plus 1. That means 0.2. Okay? When n equals to 0.1. Okay, why do we choose 0.1? It's because the question given is n tend to 0. We start from 1, then become 0.1, then we become 0.01, then we become 0.001. The number is getting smaller and smaller and nearer to 0, right? So when n equals to 0.1, this equals to 4 plus 0.1. And what is the value of this? One divided by 4.1 is 0.2439. Okay? When n equals to getting smaller, 0.01, then it becomes 1/4 plus 0.01. And how much is this? 0.249. Okay? 94. Make it 4 decimal places. When n equals to 0.001. Okay? 1/4 plus 0.001 equals to 0.2499. Okay? When n equals to 0.0001, we get 1/4 plus 0.0001. Okay? 1 divided by 4.0001. We get 0.25. Right? So as we can keep going on, making the numbers smaller, and smaller, and the final answer we will get is 0.25. And what does that mean? That means when n is getting nearer to 0, meaning you see this n number is getting more 0 at the back of the decimal point. When you're getting nearer and nearer to 0, these equations 1/4 plus n will equals to 0.25. So limit n tend to 0, 1/4 plus n equals to 0.25. Now let's take a look at these questions. Given limit n tend to 1/n plus 7 equals to 1. So how do we solve this question without writing out? When n equals to 0.9, this equation equals to 1. When n equals to 0.99, this equation equals to 1. When n equals to 0.999, this equation equals to 1. So without us writing out everything that I mentioned just now, how do we solve these questions? Okay, so first, write 1 equals to 1. When n tend to 0, so we just put n, we substitute 1 into n. So n become 1 plus 7. And what we got? 1/8. However, this is not always the case by substituting 1 into n to solve these kind of questions. Let us take a look at another example that we cannot just simplify, substitute the value of this into the unknown. So given by questions, limit x tend to 3, x squared minus 9 over x minus 3. So let's see what will happen if we're using the same method up here. Right? X tend to 3, meaning we substitute 3 into this x. Alright? So x squared we get 3 squared minus 9. X is 3 minus 3. So what do we get here? 3 squared equals to 9. 9 minus 9, 0. 3 minus 3, 0. So this is undefined. So by solving these questions using by substituting 3 into x doesn't solve this question because it's 0 over 0. It's undefined. So when we get undefined answer, we do it another way. Limit x equal to 3, x squared minus 9, x minus 3. So first we simplify this part first. How do we simplify? X squared minus 9, we can write it as x plus 3 minus 3. X minus 3. Okay? How do we get these two from here? Okay? Here, let me write it over here. X squared minus 9. X squared minus 9. We can write it as x squared minus 3 squared, isn't it? Right? So x squared minus 3 squared. How do we further simplify this x squared minus 3 squared? By x plus 3 multiply x minus 3. We get this one. You see, x multiply x, x squared. X multiply 3 minus 3 minus 3x, but we get positive 3x over here. Cancel off the x. Positive 3 multiply negative 3, we get negative 9. So meaning negative 3 squared. Right? So when we form it into this format, we can see that x minus 3, x minus 3 can be cancelled out. So this will balance have x plus 3. Okay? Then now we substitute 3 into x. So what we got here is 3 plus 3 and we got it 6. Okay, now let's take a look at differentiation as the gradient of a tangent to a curve. And what does this topic about? It's about curve and tangent. So let us take a look at this. This is a curve. So let's say here we name it point P. Here we name it point Q. And the coordinate of P we say is x, y. X and y is the coordinate of P. Then Q will be x plus theta x, y plus theta y. Alright? This symbol, we read it as theta. It means a little bit, small amount. Okay? X plus small amount of x. X plus theta x. Y plus small amount of y. Y plus theta y. Right? So if we draw a line connecting P and Q, okay? So what will be the gradient of PQ? So gradient of PQ will be, remember how to find gradient of given 2 points. So it is first y plus theta y minus y over x plus theta x minus x. And what we got here? Y minus y cancel out. Alright? X minus x cancel out. So the balance are theta y over theta x. Imagine this point Q is moving closer to point P along this curve. At the end of the day, line, this PQ line become this black color line, and we call this black color line tangent. We name this line tangent, meaning a tangent is a straight line that intersects a curve at a point, at only one point. So when Q is getting closer to P, theta x tend to 0. When theta x becomes smaller, tend to 0, it will become x. Right? So by definition, you can say that gradient of tangent ENT is equals to limit theta x tend to 0. Gradient of a straight line is theta y over theta x. Theta y over theta x. So limit theta x tend to 0. Theta y over theta x. This is the gradient of the tangent. At the same time, you can say this is dy dx. Okay. Now we are given this curve y equals to x squared plus 5, and we are asked to find the gradient of the tangent using the concept of differentiations, right? So this is the curve y equals to x squared plus 5. Okay, so we name it. Okay, this one we say point P, this one we say point Q. What are the coordinates of P and Q? Okay, P, X, Y, right? We are given point P and point Q are on the curve of y equals to x squared plus 5. So the coordinate of P is x, remain x, right? Y. What is y? When x equals to x, so we substitute x into here, then we got y will be y equals to x squared plus 5. X squared plus 5. This is the coordinate of P, x and x squared plus 5. How about Q? Q, we just add a theta in it. We replace x into x plus theta. So the coordinate of Q is x plus theta x. How about the coordinate y? Okay, so we substitute x plus theta x into x. So here we got x plus theta x squared plus 5. Right? This is the y term. This is the y term. Okay? So let's find the gradient of the line PQ. Gradient. PQ. So gradient, this one minus this one. X plus theta x squared plus 5 minus x squared plus 5. Remember to bracket it because there is a negative over here. It will affect the positive negative inside in this unit, alright? X plus theta x minus x. So what do we got here? We expand x plus theta x squared. We expand this one, alright? So x, we get x squared plus 2 theta x plus theta x squared. Alright, this one. Expand this one. So we plus 5. Here we got negative x squared. Negative x squared. Negative positive negative 5. This is the reason why we need to put a bracket instead of just put negative x squared plus 5 because it affects the negative and positive of 5. So here x plus theta x minus x. Alright? Take a look. X squared cancel off. Cancel off. Okay? Plus 5 minus 5 cancel off. X minus x cancel off. So in the end, what we got here is 2 theta x plus theta x squared over theta x. And here we can further simplify it, become theta x 2 plus theta x. Alright? This one is theta x. Cancel off. And what do you got here? 2 plus theta x. Now, then this is a gradient of PQ. So we are asked to find the tangent, right? So tangent at point P, okay? Gradient of tangent at P. So you will become limit theta x tend to 0. So this is the gradient of line PQ. So it will become 2 plus theta x. Okay? So when theta x tends to 0, then here become 2. So therefore, dy dx is equals to 2. And 2 is the gradient of tangent at point P. Now we are asked to find the first derivative of this equation from the first principles. What does that mean? That means we add theta y into y, add theta x into x. Okay? So this is the equations. Y equals to 4 plus x squared minus x plus 5. So when we add theta in it, it will become y plus theta y. Alright? X squared will be 4x plus theta x squared. Okay? Minus x plus theta x plus 5. Alright? This one left hand side remain x plus theta y. This one we expand. 4 x squared plus 2x theta x plus theta x squared. Okay? Minus x minus plus become minus theta x plus 5. Now we multiply 4 into this one. So left hand side remain y plus theta y equals to 4x squared. 4 times 2 is 8x theta x plus 4 times this one 4 theta x squared minus x minus theta x plus 5. Okay? Then we this equation minus this equation. So we name it this equation number 1. Okay? This is equation number 2. So equation number 2 minus 1. 2 minus 1. Here, y plus theta y minus y, we got theta y equals to 4x squared. 4x squared cancel off. Then let's take a look at x. Okay? Minus x minus minus x. Cancel off. So here cancel off, here cancel off, cancel off, cancel off. Okay? 5 minus 5. Cancel off, cancel off. So here cancel, cancel. Okay, what we have here? Balance 8x theta x plus 4 theta x squared minus theta x. Right? So we take out x, theta x, theta x, theta x. Then here we got theta y equals to theta x 8x plus 4 theta x minus 1. Okay? Theta x, we move it to the left hand side, it will become theta y theta x equals to 8x plus 4 theta x plus 1. Then dy dx is equals to limit theta x tend to 0, theta y theta x, and this is this is also equals to limit theta x tend to 0, theta y over theta x is equals to this one. So it's 8x plus 4 theta x plus 1. Right? So here we got the substitute 0 into theta x. So 4 multiplied 0 will be 8x plus 4 multiplied 0 plus 1. So we got 8x plus 1. So meaning the dy dx of this equation y equals to 4x squared minus x plus 5 is equals to 8x plus 1. Okay, now let's take a look at another example. Given by the questions, we are asked to find the first derivative from the first principle. So the equation given is y equals to 3x plus 2. So by adding theta y into y, theta x into x to solving. So y at theta y become y plus theta y equals to 3 over x plus theta x plus 2. We name this equation number 1. We name this equation number 2, alright? So equation number 2 minus equation number 1. Okay? 2 minus 1. So x so y plus y theta y minus y, we got theta y. Okay? So 2 minus 2. With this 2 cancel out. So balance 3 over x plus theta x minus 3 over x. So make it into common denominator and we will get x multiply x plus theta x will be the denominator. Alright? So 3 multiply x, 3x minus 3 multiply x plus theta x. Got it? Expand it, become 3x. 3 multiply x become minus 3x plus 3 minus 3 theta x. Okay? The bottom one we got x multiply x squared plus theta multiply x become theta x theta x. Okay? 3x cancel off. So we got theta y equals to minus 3 theta x over x squared plus x theta x. So we move this theta x to here, left hand side. We got theta y over theta x equals to negative 3 over x squared plus x theta x. Right? And then now we are looking for dy dx. So dy dx equals to limit theta x tend to 0, theta y over theta x. and this also can equals to limit theta x tend to 0, the whole thing minus 3 x squared plus x theta x. And now we substitute 0 into theta x. So 0 substitute into theta x, and this term will become 0. So we write it this way, minus 3 x squared plus x multiply 0, and what we got here is minus 3 x squared. So meaning the dy dx of y equals to 3 over x plus 2 is equals to negative 3 over x squared. And if you have any questions regarding this subtopic, feel free to comment below this video and we will further explain it to you.